Hello, and welcome to the session on proportionality. We'll deal with both directly proportional as well as inversely proportional relationships in this particular session. We will also look at some solved examples. To begin with, what exactly does directly proportional mean? Well, two quantities are said to be directly proportional to each other if, on the increase or the decrease of one, the other one increases or decreases. It is typically represented like this, where A is proportional, this is the proportionality sign, to B, or A is equal to KB. K is my proportionality constant. Now, what does this mean? This means that when A doubles, B doubles. When A halves, B halves. When A becomes 17 by 5 times, B also becomes 17 by 5 times. When A increases by 10%, B increases by 10%. When A decreases by 10%, B decreases by 10%. And the same logic continues. Now, it is not necessary that the powers or the degree of A and B are going to be the same. However, let's say for something like this, when A is directly proportional to root B, what does this mean? This means that A is equal to a proportionality constant into root B. That is when B becomes 4 times. Let's say if B dash here is equal to 4B, then what will be A dash? A dash will be double of the original, or A doubles. If B becomes 1 by 9 times, what will A become? A will become 1/3 because of the square root here. If B increases by 21%, well, what happens in that case? Does A increase by root 21 or does it increase by 21? Well, use your logic. If B increases by 21%, it becomes how much? It becomes 1.21 times the original. And if B is 1.21 times the original, then root of B is 1.1 times the original. Or that means A essentially is 1.1 times the original, or it has increased by 10%. Very similarly, what happens when B decreases by 19%? Let's say if it decreases by 19%, 100 minus 19 is 81. So it becomes 0.81 times the original, or B dash is 0.81 times B. Root of that, well, that is 0.9. So A becomes 0.9 of the original, or it decreases by 10%. That is how you can use the directly proportional relationship. The inversely proportional relationship is very similar. The only difference is when A increases, B decreases. And same stuff keeps on happening. Let's say if A decreases, then B will increase. I think I have the wrong equation here. This should be A is equal to K by B. So what does this mean? When A doubles, B halves. When A halves, then B doubles. They are reversed, as you can see. I think will be clearer from this. When A becomes 17 by 5 times, B becomes 5 by 17 times of the original. So it is multiplicative in nature, it is becoming inverse, it is becoming reciprocal. So how about this one? When A increases by 10%, then B should decrease. Okay? And B should decrease by how much? That is the question. Should it decrease by 9% or 10%? Well, think of it this way. When A is increasing by 10%, that means A is becoming what? A is increasing by 1 by 10, or you can say that A is becoming 11 by 10 of the original. If A is becoming 11 by 10 of the original, B will become 10 by 11 of the original. And if B is becoming 10 by 11 of the original, what does that mean? It means that it is fallen. And how much has it fallen by? It has fallen by 1 by 11 and 1 by 11, which we have here. It has fallen by 1 by 11, and 1 by 11 is what percentage? 1 by 11 is 9.09%. Let's use the same logic again. What happens when A decreases by 10%? that means A is going down by 10% or 1 by 10. That means A becomes 9 by 10 of the original. So B will become 10 by 9 of the original, or B will go up by 1 by 9. And that's why 1 by 9 is 11.11%, and that's how you get these values. Very similarly, looking at something slightly more complicated, when A is inversely proportional to root of B, or A is equal to K root B. What does that mean? That means when B becomes 4 times, root of B becomes 2 times and A halves. When B becomes 1 by 9 times, that means root of B becomes 1 by 3 times, A will become the reciprocal or 3 times. B increases by 21%. That means an increase of B, how much is the increase in B? 21% is the increase in B. That means it is becoming 1.21 of the original. So root of B is becoming 1.1 of the original, which means root of B is going up by 10%. And as we know from here, if one property increases by 10%, the other one will have to decrease, and by how much? It will have to decrease by 9.09%. Or you could have also seen that since B is increasing by 10% or B is increasing by 1 by 10, then the same thing which we did here, 11 by 10, 10 by 11 and so on. How about this one? B decreases 19%. That means B is becoming 0.81 of the original. So root of B is becoming 0.9 of the original. That means B has fallen by 10%. And if one quantity falls by 10%, the proportional increase in case of an inverse is 11.11%, as you can see from above. So these are some of the key ideas behind directly and inversely proportional relationships. Let us look at a couple of questions. Before you see the solutions, I request you to try these questions out on your own. You can pause the video here. Let's continue. So what am I given? I am given 60 liters is required for 600 kilometers using a 800cc engine. If the volume of the diesel required to cover a certain distance varies directly as the capacity of the engine. Okay, so the volume required is directly proportional to the capacity. Cool, that is one relationship we have. Obviously, the fuel that you require will be proportional to the distance that you are traveling. That is a given. So 60 liters is required for 600 kilometers. So we have 60 liters is required for 600 kilometers, which is a direct relationship, and we are using a 800cc engine. Now, the question, however, is that how many liters is required for 800 kilometers using a 1200cc engine. So how do I calculate this value? First of all, whatever was the original value that I had, the required distance has become 800, or I can say 4 by 3 of the original. From 600 to 800 it has gone, or it has become 4 by 3 of the original. How about the engine? The engine has gone from 800 to 1200, which is how much? That has become 3 by 2 of the original, and these are all directly proportional relationships. So this is what you will get. Calculating it 4 by 3 into 3 by 2. This 3 will cancel with this 3. 2 and 60 will cancel and give you 30. 30 into 4. So you get 120 liters as the answer for the first question. Let us look at the second one now. The speed of a railway engine is 45 kilometers per hour when no bogie is attached. Okay, so your default speed is 45 kilometers. It is observed that the reduction in speed is directly proportional to square root of the number of bogies attached. Okay, So that is one information that I have. So I can write this as reduction in speed is equal to the proportionality constant into square root of n, where n is the number of bogies which is attached. What do I know? If the speed of the train is 9 km per hour, okay, so if the speed of the train is 9 kilometers per hour, what is the reduction? From 45 the speed has gone down to 9. There is a proportionality constant k and square root of number of bogies is 16. So that gives me the value of k as 45 minus 9 or 36 square root of 16 being 4 as 9. So I get my equation as reduction in speed as 9 square root of n. Now, what is the maximum reduction that I can do? Well, the maximum possible reduction that I can do is 45 and then it will not move. And when do I get that 45? I get that 45 when square root of n will become 5 or n is equal to 25. What does that mean? That means that if there are 25 bogies attached, the train will come to a complete halt or the railway engine will come to a complete halt. But we know that that is not what we are looking for. What are we looking for? We are looking for the maximum number of bogies that can be carried. If it becomes 25, the engine does not move. So what is the maximum number of bogies that can be carried by the engine? Well, one less than that. So the maximum number of bogies that can be carried is 24. Because as soon as you attach the 25th one, the reduction in speed is 45 kilometers per hour, and from 45 the speed comes back to 0 and the engine will not be able to move. With this, I'd like to wrap up this session. Please provide feedback via Twitter or via email. My mail ID is ravihanda@gmail.com. Thank you.